In this tutorial, we're going to show you how to take a full 3D model, import it into the software and unwrap it to create toolpaths to cut on a rotary axis. So let's go to File, Close, and so we'd start by creating a new file. So in the job setup form, you need to specify a rotary job type. And then in the job size, this is where we specify the actual cylinder that we're going to cut into, in which case I am using a cylinder that is 12 inches in length and is 4 inches in diameter. Then we move on to our Z0 position. We have two options. We've got the cylinder surface or we have the cylinder axis. And this is going to be the most reliable choice as it's much harder for you to set your Z0 off the outside edge of your cylinder because that requires your cylinder to be a perfect circle in order for that to be correct. So we're going to go with the cylinder axis here. And this is the equivalent in the software to setting your Z0 to the bottom of the block on a regular 3-axis job. Then we move on to the XY datum position. My setup is in the lower left hand corner, and then we need to specify our orientation, and this is where we choose to wrap the Y values around the rotary axis or wrap the X values around the rotary axis. So really this is dependent on the orientation of your CNC's rotary axis. So you'll need to check with the manufacturer or just simply look at your CNC in order to see which setup you have. Now for demonstration purposes we're going to make that along the X-axis, so we're working with a linear axis in X, where we're going to look at wrapping the Y values, so we're going to use this option here. Now as we are importing models, we're going to look at the modelling resolution, in which case I'm going to set that to be very high, and then we could choose our appearance. In this case I'm just going to go with a Canadian maple, and then we could go ahead and press OK. So the software will automatically create a job for us based on the dimensions that we entered in the job setup form. So you can see we have a width of 12 inches, so that's our X-axis, and that's just as we specified in the job setup form. And then the height is defined as if it was the circumference of our cylinder, and it's taken that 4-inch diameter and it's basically unwrapped it. And everything that we do in the software is going to be calculated in a flat environment. And the only time that the output of that will change is when we use the post-processor that has the ability to do that. But we are able to visualize our part in a rotary environment in the 3D view. And then the depth that we've got here is 2 inches, and that is basically half of the diameter that we specified in the material form. So let's switch over to the modeling tab. And then we're going to look at using this option here to import a component or 3D model, which we could then look at unwrapping into our job. So we're going to use that, locate the file that we want to unwrap. So here I have a solid handle.3dm file, and this is a 3DM file that was created in Rhino software, and this is one of their demonstration files. So we're not able to supply this data for you, but if you watch this video you should be able to apply the same principles to your own files. Okay, so I'm just going to maximize the 3D view over here, and then we'll just put that down the Z-axis. Now as this is a non-native file, the software will automatically open up the Orientate 3D model form, which allows us to set the model up before it's brought into the job and converted into a standard component. So here we need to orient and size the part so that we can unwrap the part correctly. We'll first look at orientating the model, and then we'll look at sizing the part afterwards. So the first option you're presented with in the form is the model type. Okay, so we have full 3D model or we have flat model. In our case, we're actually working with a full 3D model where we want to machine it as we see it right here. You'd use the flat model option if, say, you were bringing in a flat 3D model, which is typically known as a relief model, something that you wanted to apply to a wrapped part, but that is covered in a different tutorial. So this example, we're looking at unwrapping a full 3D model. So we're going to look at this as if we were looking down the y-axis of our machine. So the blue frame represents the bounds of the model as it's positioned here. And this red area represents the linear or the rotation axis, which in our case is along the x-axis. Now the software will try to guess the initial orientation that it sees most appropriate based on our initial model type selection. So in our case we selected the full 3D model, and so the software will position the model in the center of our material block so that the material is used more efficiently. But this initial positioning of the model will need tweaking so it can best fit our part according to the rotation or the linear axis. So we have various options within the form to orientate and move the model within our cylinder. First off, let's have a look at the initial orientation. Now, just looking at our model as it stands, it looks pretty good, and it only really require us to tilt the model slightly in the y-axis where we're bringing this area down so that it becomes more in line with our cylindrical axis or the rotation axis there. But we're going to go and show you all the different options. Sometimes when you bring models in, you do need to work through each one of these until you find something that looks appropriate to sit within the actual cylinder itself. Okay, so right would look like this. If I zoom out, the front orientation would look like this. We have the bottom, which is pretty much the opposite of the top there, and then we've got left. Okay, not really convenient when this is our rotation axis, and then we've got the back. Okay, so like I said, I'm going to go back to the top. I think that is the most appropriate in our case. And then we also have the option to set up the orientation where we can rotate this model around the z-axis. For example, plus 90, plus 180. If we take that back to 0, that's what it looked like. Negative 90, negative 180. Again, I'm just going to take that back to 0 as I like where that's positioned. And so you really want to just switch through all of these options until you are happy with the orientation of the model. I can see that the most appropriate option was what the software had defaulted it to originally, which is the top with a 0 rotation. So once you're happy with the initial orientation, then we can think about the interactive rotation of our part. So by default, the software automatically has the XYZ view interactive rotation switched on. This basically means that we can just view our part like so. We can move it about all axes like you can see I'm doing here. And if we just view that down the Y axis, we also have the option to rotate the model itself, where we can constrict it to a particular axis or all axes. So let's do that. So we'll go XYZ, where we're just rotating the model, and you can see as I'm moving it, we're moving that in all axes, like so. Okay, don't really want that in that position there, so I'm going to press Control Z on the keyboard, and that's going to undo that move for me. Then we could look at just locking one of the axes. For example, let's take X. See, we're rotating that with X locked in place. Again, Control Z. We can have a look at locking Z, and again, can make that change. Again, this is not really appropriate for the position of what I want to do, so I'm going to press Ctrl Z, and really it's only the Y axis that I need to look at changing. So I really just want to tilt our handle down, just so that we're obscuring the rotational axes. So to do that, I'm just going to click that in small increments, just using my left mouse key to put that into a somewhat usable position. Okay, once you're happy with the position, make sure you go back to XYZ view so that it doesn't move anything out of the locked axis that you were using to rotate the model. Right then, so over to the left I can see the rotational axis in the centre there, and I can see it's been obscured all the way through because of our model, and then it comes out on the other side over here. So the idea is it'll cut our part something like this. Okay, now one thing that we need to be wary of, and that is undercuts. If we take a look at this area over here, we can see that where we've positioned the model according to our rotational axes, we're going to have a little bit of an undercut there. And we really don't want any undercuts at this stage, because when we come to unwrap the model, as we are working in a 3-axis environment, we're going to see some strange results where the software has to fill this undercut area with material. So what I need to do is, if we just put that back in the y-axis, I could look at continuing to alter the y-axis there like so, or another option that we have is to look at the rotational axis movement. So this is where we can move that linear or rotational axis up or down according to where we want it. So if we go ahead and switch that on, okay, so we simply just move this around to the other side. Okay, so this is my problem area. Now to move your rotational axis, just simply press Control with your left mouse key, and you can move that to any position you like. All I want to do here is just nudge it down ever so slightly, so it's almost at the tip of the handle. Then we want to switch that rotation axis off. Okay, so it's coming through here, going through our handle, and then if we just come over and pan to our end point here, we can see that it's pretty much on the edge of that handle. So that's okay, I'm not going to have an undercut there, this is going to be the centre. This is also where I'm most likely going to have a tab, and we'll come to that later on. Okay, so that is one way of really trying to move your model around to avoid the undercuts, combination of orientation, interactive rotation, and your rotation axis movement. Now if you had something like a figurine where you had spaces between the arms and the legs and the body, that material will most certainly get filled in. Also, if you had a highly curved cabriole leg where the cylinder may be passed out of the job and then back in again, that would also create some very odd effects with the 3D model. But with a combination of playing with the interactive rotation and the ability to adjust the rotation axis, sometimes you can get round some of these more complex style models. For example, we're going to take a look at a cabriole leg. So we can see the rotation axis runs through our model, and then as our model curves down and back up again, the actual rotation axis is visible. Okay, so if we was to machine this as is, here we would see some very strange areas, as this area would be filled in because it's essentially an undercut. So the idea here is we want to look at really obscuring our rotation axis so that we don't have any undercuts and we can cut the model as best as we can as it is. So we're going to look at using a combination of the interactive rotation along with adjusting the rotation axis movement to really try to obscure that axis so that we can get a model that doesn't have any undercuts. So I'm going to start by looking at tilting our model using Y. So I'm just going to tilt that ever so slightly like so, and then I'm going to put that back in XYZ view, and then we're going to go to the rotation axis movement and switch that on. So I'm going to zoom in slightly there, and then holding down Control, I'm just going to drop this down using my left mouse key. The idea here is I want to basically hide all of the red areas that represent the rotation axis. Okay, so I think I may have got that there. So we'll switch that off, and then we're just going to spin this round. Yep, you can see I've completely cleared that, and if we was to machine this, this would be pretty perfect. We've got a tiny bit at the end there. This isn't really an issue here. I could make further adjustments to obscure that, but I think this is pretty good as we have here. So we'd have no undercuts, and it's still worth noting that you may have some models that are impossible to hide the rotational axis, and therefore you will see some strange effects with your 3D model when you come to unwrap it. It's also worth noting here that when you do adjust the rotational axis, you really want to avoid adding detail to areas of the model that are near the rotational axis, because your tool will find it difficult to machine those areas. Now, one other thing I wanted to talk about is this red arrow. So this red arrow basically represents the z-axis, and it's basically telling us that when we come to import the model, what we see here is, if we were looking down z, will be the center of our component when we come to unwrap it. Right then, so let's go back to our original model. So now that everything is orientated as I want it to, we can now think about the size of the part. So we want to make sure that the size is appropriate to the size of our cylinder. And we can see, looking at the model scaling section of our job, that our model is significantly larger than that of our work area. And we can see this indicated by the model diameter in the form. And this may be down to the fact that the units that the model was created in might have been in millimeters, in which case 1 millimeter is being represented by 1 inch. So if we change that to millimeters, you can see that that will basically decrease the size for us. We can see now our model diameter is 4.7511. And so this red frame that we can see here represents our actual cylinder that we set up right at the start of this tutorial. We can see that the model actually surpasses the limitations of our cylinder size. So we need to look at either altering the model size or change the material that we're working with to fit the model. Okay, so we can do that all within the form. So here we have the option to adjust the model diameter. We can also adjust the model length. We have the option to lock the ratio, so when I alter one of these values, it will automatically change the other option so that it's all in proportion with each other. Or I could unlock the ratio, where I can just alter just one of these values, and obviously that would end up distorting the model slightly. We have the option here to scale the model to fit the materials. If I click on that, we can see that that is now within my cylinder. We can also look at resetting that to the original size. Okay, so you have lots of different options to size it. I'm going to scale it to fit within my material. I can see here I have enough room for some tabs to go in place there, and if I wanted to, I could make that a little bit smaller. So say let's make that 9 inches instead, or maybe you could make that 9.5, and you can see it's just constantly updating there. And actually I'm going to go with 10. Right then, so once we're happy with everything, it all fits within our cylinder, we've got the orientation correct and everything's as we want it to be, then we could simply go ahead and press OK to import that into our session. Okay, so we can see that the software has automatically put this in a wrapped view, and it's showing us the finished part as it would look if we was to actually come to machine this. So I'm just going to switch off the material block visibility, and I'm going to just temporarily just toggle off the wrapped view so we can see our part as if it's unwrapped. Now we got to remember we are working in a 3-axis environment here, and that's very important to understand that we're always working with a 3-axis part, and the only time it's going to become rotary is when we post-process this with a compatible post-processor. And so this is when, in our case, the Y values will become rotational values. So now I need to think about when we come to toolpath this model and cut it out on the machine. What is going to be keeping this model where it is when we've completely cut it out? If we didn't add anything to the model which would act like a tab to hold it in place during machining, it would break free, and that's pretty much the end game of your rotary job. So what we're going to do is we're going to look at creating a cylinder that will run through the centre of our model, small enough so it doesn't interfere with the shape itself, but thick enough to maintain the part being cut where it is during machining. Now in the modelling tab, when we create a rotary job, the software will automatically create a zero plane component for you to make use of. In our case, we can look at applying height to the component to create our tabs. Okay, so the first thing I'm going to do is select the handle, go into the component properties. We're just going to set the combine mode of that to merge. And we're going to click on to our zero plane. So for the zero plane, we want to create it to the radius of the height that you want the diameter to be. For example, if I wanted a 1-inch diameter tab, I'd simply put in a base height of 1/2 inch, and then that would create that for me. Okay, so that seems a little bit too excessive, so what I might do is look at shrinking that to 1/4 inch in there, like so. Okay, so that's not too bad, and then we can just simply close that out, and I've got a 1/2 inch diameter tab at the end, and this will provide us with some material to cut down to when we create the toolpaths, and it won't end up cutting the parts out of our piece of stock. So now our part is prepped for toolpath calculation, we can now switch over to the toolpaths tab. So the first thing that we want to do is go into our material setup. So we want to check over the settings and ensure that we basically replicate this setup when we come to machine our part. So the diameter here we're going to go 4 inches. XY position, mine's set up to the lower left hand corner, so I'm going to specify the lower left here. Z0 position, I'm going to set that to the centre of my cylinder. Then we move on to the model position in the material. So this is basically where our model sits within our cylinder. Currently it's automatically set it so I have a gap outside of my model of 0.1529. Okay, so I'm going to leave that there, and this could be useful if you did have any inconsistencies in your material. So we've just got a little bit of a gap surrounding the cylinder before it gets to our model. Then you want to check over the rapid Z gaps above the material and your home start position and the Z gap above the material to ensure that everything is safe and appropriate. So I'm just going to put in a clearance here of 1/2 inch and then 1/4 inch for the plunge, and then Z gap of the material go 2.5, and I'm just going to go ahead and press OK. So now we can go and create a 3D roughing toolpath. Now I'm going to use the same tool for both the roughing and the finishing to avoid changing tools. I don't have a particularly detailed model, so I can get away with using a large ball nose for both the rough and the finish. So in here I'm going to use the select option. We're going to select the 1/4 inch ball nose, and I'm going to use the edit option just to go over some of these settings, because this is a roughing pass. I want to make sure that what we have in here is applicable to the actual rough machining. So I'm going to change the pass depth here. We're going to make that 1/4 inch, and then the step over we're going to increase to 40%. Then I could go ahead and press OK. We're going to use the model boundary for our machining. No boundary offset here. We're going to have a small allowance of 0.03 in there. And this is just basically an imaginary thickness of extra skin that will be left on the finished material, so we avoid chipping the finished part on this pass. Then we're going to go and choose a strategy. In this case I'm just going to do a basic Z level where we're rastering in X, and then we could give that a name. We'll call that one 3D roughing, and then simply press calculate, and then that will create that for us. So now what we can do is we could go ahead and preview that. So if we preview that toolpath, we can see what that should look like. Okay, so this is our roughed part. Okay, if we just spin that round, we can see how that is going to look. Let's put that back in Y, and then we can close out there, and now we can look at applying a finished toolpath. So as I said, we're going to use the same tool, so we're going to use the 1/4 inch ball nose in here, and then if we go to edit, we can just check over those settings. Okay, so they seem okay. If I wanted to, I could decrease that step over to maybe 8%. 10% seems reasonable, so I'll just go ahead and press OK there. Again, we're going to use the model boundary. We're going to have boundary offset of 0, and then we choose how we machine this. Okay, so we're going to go with a raster strategy, and then we have the option to choose the raster angle. Now at 0 degrees, what will happen is the tool will cut along X before stepping over, and so this direction is very important when doing a rotary setup. So what would happen is the tool is going to cut along the X-axis, and then there'll be a short rotary move which is the equivalent of the step over, and then it will raster back again, do that rotary move, and then back and forth and so on. If you chose to put in 90 degrees in here, so that the toolpath was going in this direction, then that would be the equivalent of the part spinning all the way around, with the tool then stepping over in X, and then it's spinning all the way around again, and then going over in X. Okay, so I'm going to put that at 0, and this really just depends on your part and setup. Okay, so I'm going to go call that one 3D finish, and then go ahead and press calculate. That's going to calculate that for me, and then we could look at previewing how the actual cutout should look when we come to run that on our machine. Okay, so it's calculated that for us. So now what we could do is we could go and preview that toolpath. Okay, and that is what our part would look like. Okay, so you can see we've got our tabs in place. We've got quite a nice finish there. We've got enough detail. Like I said, the model isn't very well detailed anyway, but we've got a nice finish there. So at this stage we could go and close out the preview toolpaths form, select all of our toolpaths, so we're using the same tool. We could go and save the toolpaths, ensuring that we output all the visible toolpaths to one file. And then we need to choose the appropriate post-processor for your machine. And it's very important to note that it has to be a post-processor that supports rotary moves. And this is the stage where the software is going to take what are essentially 3-axis calculated toolpaths and then convert them into rotary. The post-processor has to support rotary and needs to be set up so it's configured correctly for what your rotary axis is. For example, I'm using a Mac 3 control software, and we have special posts that wrap X to A and some that wrap Y to out, you can see in here. Now in our case we are wrapping the Y values, so we'd choose this option where we're wrapping the Y axis to A being the typical designated G code for a rotary move, so I'd use that option there, and then we could simply go ahead and save out the toolpath like so. Now in this case I'm not actually going to cut this, I'm just going to cancel out there. And so that really concludes this tutorial. I'm not able to save this file as I am unable to share this data as I mentioned at the start of this tutorial. However, this process that you've seen here should work with any model that you wish to unwrap. And it's worth pointing out that you don't have to use solely 3D toolpaths, you can combine that with appropriate 2D and 2.5D toolpaths also. So that completes this tutorial. Thank you for watching.